Okay, so where are we? The method of cylindrical shells. We went through this example over here. Again, the picture I lifted from a textbook. It's typical, draw the picture of the shell and, get the three dimensions to it to find out the volume of the box and then integrate it over the range and values. I also do it by disk method, really relates to a power section. We talked about it last time. Now we're moving on to examples. There's going to be one example given, and I'll go to the whiteboard now and I'll do that example. All right, so let me give you a moment to do that. And there's really not much to say about this. I realize for some students, it's not well understood. They can't visualize what we're being asked to do. But let me see if I can do this for you. I can try to visualize what they want. And I want to do this by shell. I want to do this by shell. So this is an example. Again, we have an answer key for you. We'd like you to look at the answer key as well. Right now, what happens to a lot of students, I've observed students over time, a lot of students will look at this and they'll take their little fingers and they'll do this and say, oh, gee, I see this. And they run their finger all over the page and then they flip the page. You say, I'm done with that. You're not done with that. You haven't done anything. Pointing at something doesn't mean you can do it. What I need to do is I need to understand the problem. Can I do this without staring at the blue area and saying, gee, you did a good job? I don't know if I've done a good job. I want to see if I can do a good job. So what do I do over here? I got two problems. I'm going to pull them aside for you. And the problems are going to be, 27 minus x cubed, and the other one's going to be 27 minus 9x. And it says a region enclosed by that, right? Rotated about the y-axis. So what I'd like to do is I would just like to, maybe find out where they intersect. So I'll put this over here. So I'm going to write down 27 minus x cubed. When does that equal 27 minus 9x? Well, it doesn't look too bad. That's minus x cubed equals minus 9x. And then I'm going to say 0 equals x cubed minus 9x. Oh boy, this looks like it might go on forever. And then what do I get? I get x times x squared minus 9. So I actually have 3 points of intersection. I'll put them down for you. One is going to be 0. That's one of them. The other one's going to be 3. And the other one's going to be minus 3. And that's the x values, by the way. I'm getting it from up over here. We'll put the points down. So if I get 0, what would I get? 27. If I get 3, what would I get? That would be 0. If I put down minus 3, what would I get? Well, that's going to be 54. Let me see if I did that right. Yeah, 54. Not so bad. So I'm going to go back and read it. I got 3 points. It says, use the shell method to compute the volume obtained by rotating the region enclosed by the graphs as indicated about the y-axis. Well, before I do anything, I certainly want to be able to graph this thing out. And then we'll talk about the region in a second. So let's take a look at this. I got to put the line in. And the line is going to be, let's see, 27 minus 9x. Someone says, why are you doing the line first? It's easy. So x would be 3. And it's got a slope of minus 9, right? So that's going to be something like this over here. So did I say x is 3? I'm sorry, I made a mistake already. I'm dizzy or something. Sorry about that. This is 27, and this is 3 over here. And it's a lousy looking line. I can't say it enough times. It's a really terrible looking line. But I got a cubic too, right? Just a cubic over here. And I'm going to try to draw that in. So why don't you just look at the picture they drew? I prefer not to. And it's a cubic. I'm going to say a y-intercept of, would be 27, right? The next intercept over here. And by the way, I'm only concerned about this here, right? So it's a cubic problem. And the cubic problem, I got to worry about that now. X, and I'm only talking about these numbers over here now. I'm not worried about anything else in the problem. And I got a cubic there, right? And that's going to be a cubic. So let's take a look at that. And I got to put the cubic in, right? Boy, that's going to be a lot of work, isn't it? Let's take a look at that. And I got to maybe blow this up a little tiny bit. And let me talk about the number 1. And what would 1 give you? Well, if I did 1 over here, let me put this down for you. X is 1. What would the y be? It would be 26, right? If I did one over here, what would I get? I would get 27 minus 9. So with the point over there, it would be 118. So I'm starting to think that this thing looks sort of like this over here. All right. And I'm going to say this is my region now. This is a lousy looking graph. I don't need a good looking graph. Oh, sorry about that. Get my shader in. Again, I know I'm above the zero. Now this thing goes down like this over here. And if you look at this thing over here, it looks sort of like this over here, but I'm not worried about that. I'm worried about this region here. Now, what am I going to do? I got to read it. It says it's rotated about the y-axis. So it's rotated like this. So I'm going to say, I'm going to use a shell. Let's write this down. So I can put my shell down, looks sort of like this over here. If I rotate that around like that, I cut it and lie it flat. I'll put that. Again, I'm not saying I'm doing a great job at drawing a picture, but I'm just trying to visualize things, right? And I notice that this is dx here. So that'll be dx over here. This is dx. What's this dimension over here? It's 2 pi r. What's the r? It's x, so 2 pi x. What's the height of that object? Oh, that's trouble. So it's going to be upper. What's the upper curve? It's going to be that cubic. So it's going to be y equals 27 minus x cubed. What's the lower part of that? That would be y equals 27 minus 9x. What's upper minus lower? I'll put that down for you. 27 minus x cubed minus 27 minus a minus 9x is plus 9x. So this dimension over here is going to be 9x minus x cubed. All right, if you simply get 9x minus x cubed. I'm ready to put my integration down now. All right, what was the toughest part of this problem for me? Putting a graph down. Let's put this over here. So my x's are going to go from 0 to 3. I'm looking at my graph to do that, by the way. This is number 3, and this is 0. And now I'm going to do, put it down, 2 pi x. It's the volume of the box. The height of the box is going to be 9x minus x cubed. And that's going to be dx now. All right, let's see if we can do it. And again, my claim over here is the integrations, generally speaking, are not too bad. 0 to 3. That's going to be what? 18 pi x squared minus 2 pi x4 dx. You know what? I'm going to factor out 2 pi. That annoys me to no end. So I factor out 2 pi, right? So it's going to be 9x squared minus x4 dx. Do mistakes happen? I know I said a lot to you. They do. And that's the whole point of practicing. That when you practice, you're going to make less and less errors, especially when you get to exams, if you practice a lot. This is going to be x cubed over 3, so 3x cubed minus x5 over 5. Length integration 0 to 3. I'll see if I can do it. 2 pi. I got to put the 3 in, right? So it's going to be 3 times 3 cubed. And 3 cubed is 27. 3 times 27 is 81. Oh, 3 to the 5th power. Let's see. Let's see. 243. Boy, that's nasty. Minus, let's do the lower limit. That's 2 pi. It's 0. It's really not that bad. I got some work to do now, don't I? So we're going to do 2 pi. Common denominator is 5. That's going to be 405 minus 243. Let's see, 57, 157, 157, 162, 162 times 2, 324. All right, let me repeat this. On exams, we're looking for work. All right, now maybe a little graph might go a long way. Can I do a graph? Might do something for you. Can you write down the proper integration? That would do something for you. Can you integrate it? That would do something for you. And can you evaluate it for the final full credit? I'm going to pay. I don't put much weight in the arithmetic. However, the rest of the world does. Bad arithmetic really has a high cost. But let's look at the K. Let's see if I got it right. If I didn't get it right, I got to do it again. 324 pi over 5. Wow, miracle. All right, not so bad. All right, let me go to the second page. And I got to be honest with you, their region is much better than mine, much, much better than mine. So someone's going to say, you know, I don't know if I have this yet. I wonder if I can practice here. I wonder if you're going to give me a chance to try. This is your chance to try. You need to try. We need to try, do these problems here. See if you can do it. If you can't do it, get help. All right. Thank you for paying attention and hope to see you soon. Again, if you need help, please consider coming by to get help.